Length is a measure of the distance between any 2 points. It can be given in terms of various dimensions such as breadth, width, height, radius, depth, diameter, etc. The SI unit of length, as mentioned earlier, is meters. And we define 1 meter as the distance between 2 marks on a standard platinum iridium bar kept at a constant temperature of 0 degrees centigrade. On a standard platinum iridium bar, kept at a constant temperature of 0 degrees centigrade. The bar is kept in Paris, France. Other subunits of meters include kilometer, hectometer, decameter, decimeter, centimeter, millimeter, and the rest. It is important to note that these units can always be converted from one to another. Measurement of length. Length can be measured in various ways. It can be measured accurately or by approximation. A number of devices exists to enhance measurement of length. We have rulers, we have tape measures, we have meter rules, we have half meter rules, and the rest. All these devices mentioned helps in determining linear lengths. We also have curved lengths that can be measured using other techniques. We also note that the choice of the instrument is determined by the level of accuracy desired for that particular length. We define accuracy as the distance or the smallest unit that an instrument can measure. Various devices have various accuracies. Like the accuracy of a meter rule may be different from the accuracy of a tape measure. The accuracy of a ruler is different from the accuracy of vernier calipers and the rest. For example, the accuracy of a meter rule is always 0.1 centimeters. This means that the meter rule can measure a minimum of 0.1 centimeters. Another example is the accuracy of a vernier calipers, which is 0.01 centimeters. This means that the vernier calipers can measure a minimum of 0.01 centimeters. When taking measurement using these devices, we must always try to avoid the zero error or generally errors. Errors in measurements arise from poor placement of the eye while taking the reading. So, as illustrated in the diagram, the eye should be placed at 90 degrees or perpendicular to the scale, so that if the eye is not placed, maybe it happens that the eye is placed to the left of the 90-degree calibration, then we end up with a reading of 4.9 centimeters instead of 4.8. When it happens that it is on the other side, we end up with an inaccurate reading of 4.7 instead of 4.8. So the eye should be placed perpendicular to the scale to avoid an error, which we call error due to parallax. Such errors arise when the eye is not perpendicular to the scale.